might have, Brandon, okay, you might, was it in math or in science classes? Yeah, okay. It's a wonderful, okay, it's a, okay, yeah, okay. It's a wonderful mathematical piece. And what we can do is, what I can do is we can set it up, and I'll have to check it out to make sure that I'm not forgetting a step to tell you. But what we can do is we can do the same thing with derivatives. Now, if you do it in math, it's called walk the line, and we'll have to go through that first. But as an extra credit piece, you wouldn't have to do it if you don't want to, but it would definitely be extra credit. And you have to think about what you're doing, though. And what we're doing here is, if the derivative is positive, it means the function's increasing, which means the output values are increasing. If the derivative is negative, it means the output values are decreasing. Doesn't mean that the output values of the function are negative, it just means that they're decreasing. And there's a little bit more to that. So I won't have you do that until later on. Later on meaning after about another section or two. So we'll come up with that. Okay. So we've got that. We sketched them on both the same. Find the critical numbers. Now we can see that we have critical numbers. We found them here. But how would we go about analytically finding the critical numbers? Set it equal to 0. So we have to set the derivative equal to 0. The first one is pretty easy. The first factor, t equals 0. Now over here, is that in fact a critical number? Yes. Is it in the closed interval? Yes. Is it in the open interval? No. But it is definitely going to be another one. How do we find the others? Well, we'd have to say or t cosine t plus 2 sine t equals 0. And we'd have to then do some simplifying of this. So we'd have negative t cosine t equals 2 sine t. So t would be negative 2 sine t divided by cosine t. What do you know about sine t divided by cosine t? Okay, so we have, now, our critical number is where t has the same value as negative 2 tangent t. How are you going to find that? Now, if we're going to look for that value, we'd have to consider what angle in tangent divided by negative 2, well, what angle in tangent has the same value as negative 1/2 the angle's measure. Or you can go to your spires, okay, do a solve on that. Make it, if you have x in there, use x. If you have t in there, make it comma t. And come up with our values. Now we hope that they're close to 2.29 and 5.09. We hope. Are those two values within our interval from 0 to 2 pi? 2 pi is about 6.28. So, Becca, what'd you come up with? Oh, okay. I thought you were finished. Anyone?
There's a whole bunch of them.
Okay.
But there is a 2.29 and a 5.0.
Yeah, because it's saying that you have rotation on that. So we wouldn't want any rotation on that, would we? So you'd have to find it where, the rotation is 0. And so you should come up with 2.2889, or t is approximately 5.087, and it should be there. Okay, now we're not done with the problem. What did we just find? These are what? Critical numbers of the function. Now we have to go back, find the intervals in which the derivative is positive and which the derivative is negative, which means we have to set up a sign chart. And the sign chart, you know, you really only need a sign chart that goes from about 2.29 and then about 5.09. And then, you know, we don't want to go past, you don't want to choose a test value that's less than 0. So the test value might be t equals 1, t equals 3. We can't go past pi. So maybe t equals 6. So we don't go past 2 pi on that. We're out of time. Okay, I hate to make you do this, but you have to leave. So, okay, we'll finish this up and get into section, the next section. Don't forget the quiz.